Bismillahirrahmanirrahim. In this lecture, you will learn about the atomic mass, and the second objective is how can you calculate the number of atoms from the atomic mass. So first, little bit understanding about the atomic mass, and this is the reason for using the atomic mass, because the atoms are so tiny that even smallest speck of a dust visible to the naked eye contain exponent 16 atoms. So, so that means this smallest dust is containing exponent 16 atoms. So you can think about uh, how much is small is the atom, a single atom. So this is for our convenience that now we are going to use a term, and it is called the atomic mass unit, and simply we call it the delta, and it is represented by the capital D small a, or in generally we will use the AMU. So AMU is the atomic mass unit. One AMU actually is defined as exactly 1/12th mass of carbon 612, and which is equal to 1.660 son exponent minus 24 gram. So what is written over here, it is explained with a very simple formula. That means mass of one carbon 612 atom is 12 AMU. So 12 atomic mass unit. So if you want to get 1 AMU, this is going to divide with the mass of one carbon atom. So this is written over here. So 1 AMU will be equal to, this is going to divide mass of one carbon 612 atom divided by 12, and this is by calculation will be equal to 1.660539 exponent minus 24 gram. So in simply, one atomic mass unit is having a weight of 1.660 exponent minus 24 grams. So this ratio is very important to convert the weight into AMU and AMU into the weight. So this we will use for the further calculation. So whenever somebody asks you what is the atomic mass unit, so what is the actually the weight in this one? So it is the 1/12th of the mass of an carbon atom, and this carbon is carbon 612, because there are the other isotope of the carbon as well, carbon 613 and carbon 614, but here we are talking about the carbon 612. So in the periodic table, all masses are in relative to the carbon 612. So 1 AMU equal to this 1 gram. So now I'm going to use how can you calculate the number of atoms from the mass, or the if the atomic mass is given. This is a very simple example. One of the example is given over here. The if your the mass of is of a carbon is 1 milligram, that is which is going to contain 5.01 exponent 19 carbon atoms. So the question is, how can you calculate the atoms by using the weight? So weight of the carbon is a small speck of the carbon is 1 milligram. So first is to you have to convert the milligram into the gram, because this ratio, as we have discussed before, this is a ratio between 1 AMU and the gram. So if the weight in milligram or other unit is given, and we have done detailed calculation to convert one unit to another unit, so you can use that knowledge to apply over here to convert the milligram into the gram. So 1 gram is having the 1000 milligram, so you have to divide by 1000 to convert the milligram to the gram. So that's why when you divide by 1000, it would be 1.00 exponent minus 3 gram. So this is the first conversion. Now again, as we have done during the conversion of different uh, stoichiometric calculation, the unit of the weight and the length and the temperature, we use the unit cancellation method. So this in blue in color, this is the standard conversion unit. As we have discussed before, 1 AMU will be equal to this much gram. So you have to put this ratio in such a way that gram is going to cancel out with the gram. So of course you will put in denominator over here and AMU in the numerator. So 1 AMU will be equal to this 1 gram, and gram is going to be cancelled out. So what is left over here? This is AMU. So now if you divide this value with this figure, it will convert into the AMU. Now we can use the ratio of the AMU with the atom, and you know one carbon atom is having the 12.0001 AMU. And remember one of the calculation before, we have done this calculation. This is the another video we have calculated the average atomic mass of carbon 612, and this is the 12.011 AMU. So this is given in the periodic table, and you can use the periodic table to get this value. So again, this is the one carbon atom is having the 12.011 AMU. So again, AMU is going to be cancelled out. And why I have written AMU in the denominator and carbon atom in the numerator, because I want to cancel the AMU. AMU is cancelled out. What is left? Atoms are left. So when you solve this one, this divided by this, you will get the answer 5.01 exponent 19 carbon atoms. So this is very simple way you can calculate the atoms of any element or any atoms from if the weight is given. Let's suppose there is another example. How many atoms are there in 36 gram of the bromine? So here now you have to calculate the number of atoms of the bromine, and this is the mass is given over here. 1 AMU will be equal to 80. One carbon atom will be equal to 80 AMU. So you can use the same formula over here, and you can put the actually 36 gram is given, so you have to put 36 over here. This will remain the same. 1 AMU will be equal to this. So for the bromine atom, one bromine atom will be equal to 80 AMU. So you have to put the 80 over here, and when you solve by using the same way, you will get the answer. Answer is written over here, 2.7 exponent 23 bromine atoms. So by using the same formula, you can calculate the number of the atoms of any of the element if the weight is given, and of course this is the molecular mass, and in AMU if it is given, you can calculate by using the same methodology. So this is all about the atoms, and how can you calculate the atoms from the mass.